Which among the curves shown in the figure cannot possibly represent electrostatic field lines? So they are given 5 figures and we are asked us to find uh, the wrong ones which cannot represent the electrostatic field. So here the answer is except C, everything is wrong. Let us see the reason. If you take this as the conductor, so if you take what is generally a conductor, uh, a conductor will have the charge distributed on its surface, so that is called conductor. Or inside the conductor you won't have any charge. Okay, so please understand that inside that conductor you don't have any charge. And also, if this is the surface of the conductor, the electric field line should be perpendicular to the surface. Okay, it should be normal to the surface of the conductor. So if this is the surface of the conductor, it should be normal like this. Okay, but here if you see, it is not normal everywhere. If suppose if you take this point, it should be like this, but it is in some other direction, so this cannot be a correct one. And why B is wrong? You see, we have to say the electric field line starts from the positive charge and it is terminating at the negative charge, but here it is starting from the negative charge, which is not possible. So this is also wrong. C is correct because both are positive charges, so their field lines will be in this way, and in the center their field lines are equal and opposite, so they will cancel each other and they will have a neutral points here. And why D is wrong? Yes, D is wrong because the electric field lines are intersecting each other, which is not possible. And E is wrong because electric field lines cannot form closed loop. So this is the answer for this question. 2-point charges QA 3 mu coulomb and QB minus 3 mu coulomb are located 20 cm apart in vacuum. What is the electric field at the midpoint O of the line joining AB, the line AB joining the two charges? So there are two charges QA and QB equals to 3 mu coulomb and minus 3 mu coulomb respectively, and they are placed 20 cm apart. So as shown in this figure. And now we are asked to find what is the electric field at the midpoint, that is at 10 centimeter from either charge. What is the electric field? What is the total electric field that is being asked? Now if we take because of QA, what is the electric field because of QA or Q, any charge Q? It is KQ by R square, and this is the general formula, we know that. So if we take QA, this is positive and this is a negative charge. So because of this positive charge, so here field will be in this direction. Okay, but what about the minus 3 mu coulomb? Because of minus 3 mu coulomb also the field will be in this direction only. So please try to understand that point. Or to understand easily, if you keep a unit positive charge at the point O, what will be the direction of force because of QA? It will be in this direction towards right because it will repel. What about the force because of minus 3 mu coulomb on this positive charge? If we keep, it will be in this direction only because minus 3 mu coulomb will attract this positive charge. So from this we can determine the directions of electric field. So because of QA, that is plus 3 mu coulomb, electric field will be towards right side, and because of minus 3 mu coulomb also the electric field is towards right side. Okay, so now we have considered the directions. Okay, so we have to find the electric field because of QA and QB separately, and as their directions are same, we are going to add the fields. Okay, as this is plus, this is minus, we should not cancel it and we should not write 0 because they are so with the sign, that is positive or negative, we are determining the direction, and if the directions are same, then it is vector addition, then we have to add them and we should not subtract them. So let us see what is the answer. Please note that point. So EA is KQ by R square, KQA by R square. So K is 9 into 10 power 9. What about QA? It is 3 into 10 power minus 6. Mu coulomb is 10 power minus 6. What is the distance we have to take? We have to take the point, the distance from the point to the charge. Okay, so what is the distance between this point and the charge? That is 10 centimeter. 10 centimeter we have to take in meters, so 10 into 10 power minus 2 meter whole square. Okay, so this is equals to 2.7 into 10 power 6 Newton per coulomb. Similarly, if we take because of charge QB, it is here. You please understand one thing. We have already considered the direction, that is minus 3 mu coulomb, so that the direction of electric field is towards right. So again we are not going to take the sign. Okay, please try to understand that. So it is kq by r square, so it is same as that of previous one. Now, what is the answer? 2.7 into 10 power 6 Newton per Coulomb. So, what will be the resultant field at O? Both QA and QB, they have equivalent fields towards right side only. So, we have to add those two fields. Okay, please try to understand. We have to add those two fields. So, it is 2 into 2.7 into 10 power 6. That is equals to 5.4 into 10 power 6 Newton per Coulomb. And please see the next question. If a negative test charge of magnitude 1.5 into 10 power minus 9 coulomb is placed at this point, what is the force experienced by the test charge? So here they are asking us the force on this negative charge when it is placed in the center point. That is what is being asked. And we know, if we know the value of electric field at that point and charge we have placed, then we can find force is equals to charge into electric field, charge into magnitude of electric field. So what is the charge? 1.5 into 10 power minus 9 into what is we have the electric field we have found at O is 5.4 into 10 power 6. So just multiply it, we are getting it as 8.1 into 10 power minus 3 Newton. And please see how we are determining the direction. So if we see, because of EA and EB, the net electric field was in which direction? It was towards right side. Okay, the net electric field was towards right side, and we are keeping a charge like this. Okay, we are keeping a negative charge like this. So if this is the general case, if the field is like this, then we know the force on the negative charge placed in the field is opposite to the direction of electric field. Okay, so that is the reason we are taking the direction is from O to A. So the force on this negative charge will be in this direction. So that is O to A. So that is what is told. And what is the reason? If this is the direction of electric field, then we can imagine there are many positive charges accumulated here and there are many negative charges accumulated here. So the positive charges will attract this negative charge. So force on this negative charge will be towards left. Also, it is if it is negative charge, it is in the opposite direction of electric field. So from both the ideas we can get the direction. An electric dipole with dipole moment 4 into 10 power minus 9 centimeter is aligned at 30 degree with the direction of uniform electric field 5 into 10 power 4 Newton per Coulomb. Calculate the magnitude of torque acting on the dipole. So we have the value of dipole moment, we have the value of electric field. Now we are asked to calculate the torque, value of torque, and the general formula for torque is P sin theta, where theta is the angle made between the dipole moment and the electric field. So here we have the value of P is 4 into 10 power minus 9, sorry, it is not centimeter, it is coulomb meter. E equals to 5 into 10 power 4 Newton per Coulomb, and theta equals to 30 degrees. So just substitute the values and you are going to get the answer. A system has two charges, QA equals to 2.5 into 10 power minus 7 coulomb and QB equals to minus 2.5 into 10 power minus 7 coulomb, located at points A 0, 0, minus 15 centimeter and B 0, 0, plus 15 centimeter respectively. What are the total charge and electric dipole moment of the system? So yes, this is a dipole because this is here it is plus 2.5 into 10 power minus 7 coulomb, and here it is minus 2.5 into 10 power minus 7 coulomb. So their algebraic sum is 0. The net charge is 0. Okay, very well, we can see that the net charge is 0. So the total charge, that answer is 0 only. So this is the dipole moment. Okay, this is the dipole, and how do we calculate dipole moment? It is either charge into distance between those two charges. So what is the charge? We have to take it is either charge. It is 2.5 into 10 power minus 7. That is Q. And what is the distance between two charges? We have to take this whole length we have to take. Okay. So if this is the origin, from here to here it is 15 centimeter and from here to here it is 15 centimeter. Okay. So what is the total length we have to take 30 centimeter. 30 centimeter we have to convert it into meter, so that is 0.3 meter. Okay, please do not forget the conversions, it is important, otherwise the answer will be going wrong. So 0.3 meter. So the final answer is 7.5 into 10 power minus 8 coulomb meter, which is along minus z axis. Why it is along minus z axis? So please note, at point A, yes, so at point A we have positive charge, so here positive charge is present. At point B we have negative charge, so the direction is from negative charge to positive charge. So if this is plus z axis, then the direction is like this, so it is towards the minus z axis, so that is the direction. The given figure shows tracks of three charged particles in uniform electrostatic field. Give the signs of the three charges. Which particle has highest charge to mass ratio? So they have given three tracks of the three different charged particles in an electric field. They are asking us to find the sign of three charges and the specific yes, which particle has highest charge to mass ratio, that is specific charge, who has the highest one. So let us see how we are solving this question. So if we see, this is the positive plate and this is the negative plate. 1 and 2 are moving towards the positive plate, they are attracted towards the positive plate, that means they are negatively charged. And if we see particle number 3, it is moving towards the negative plate, so it must be positive charge. So that is how it is simple to get the sign of the charges. Now before going the second question, let's see one thing. So if we take an electric field, and if we are keeping a particle in electric field, if we charge a particle in electric field, we know a force is produced, right? And that force is equals to Q into E. So if the force is produced, then we know the net force is equals to mass into acceleration. Yes, we know it already, we have seen it. So I am writing here, what is the force? It is Q into E. Okay, the force on the charged particle. The force on the charged particle when kept in an electric field, it is Q into E. Now we can equate this to mass into acceleration. Okay, from this we get acceleration is equals to QE by M. So what is this acceleration? This is the acceleration of charged particle when it is placed in the electric field. Okay, because of the electric field only there is an acceleration, please note that one. So that acceleration, the value of acceleration is QE by M. Now we are going to find vertical displacement. So let me say it actually first. We know y is equals to ut plus half at square, and here the charged particle was initially kept, so it is just kept, so the initial velocity is 0, and so it is just half into a into t square. And what is this y actually? So that is displacement. So if we see this distance, or this way we have to see, this is the displacement we are talking about. Okay, so we know y is equals to half at square, half, what is acceleration? QE by M into t square. So from this we can write y is directly proportional to Q by M. Okay, so if y is directly proportional to Q by M, then we can see the deflection of particle, that is y is nothing but deflection of particle. So this is y I have told. Okay, if this is larger, as in case 3, we can observe the y is larger. Okay, this distance is larger in case of 3. Okay, so if y is larger, that means the deflection is maximum. From here it has deflected through this distance, so deflection is maximum. Okay, so that is directly proportional to Q by M. That means which has greater deflection, that has greater charge to mass ratio. From this we can conclude that is the answer. So the answer is 3 here. An oil drop having 12 excess electrons is held stationary under a uniform electric field of 2.55 into 10 power 4 Newton per coulomb. The density of the oil is 1.26 gram per centimeter cube. Estimate the radius of the drop given gravity and charge on electron. So if you see, this is the oil drop and it has excess 12 electrons. That means what is the charge it is having? 12 into E. That is the charge on this oil drop, and it is held stationary. So that means it is a negative charge. That means what will be the direction of force? It will be in the direction opposite to the of electric field, and its weight mg acts vertically downwards. So these two forces are balancing each other. Okay, now that is given in the question. Now we are asked us to find what is the radius of the drop. I think, yeah, the radius of the drop is being asked. So here I can write QE equals to mg because these forces are balancing each other. So QE equals to mg. And what is the electric field that is given? The value of electric field is given. Value of G is also given. Now the value of Q, I have already told, it is 12 into E. That is 12 into 1.6 into 10 power minus 19 coulomb. That is the charge, and that is equals to 1.92 into 10 power minus 18 coulomb. What is this? This is the total charge on the oil drop. Okay, we have to take the total charge. So that is the value of Q. Now we want to find radius, and we can see it is an oil drop. Okay, so what will be the mass formula? That is generally density into volume, and here we have given the value of density also. So volume is nothing but if it is a sphere, what is the volume? It is 4 by 3 pi r cube. That is the volume. So from this, so we know all the values except radius. So we are going to just substitute it. So please see QE equals to mg. What is value of m? That is 4 by 3 pi r cube volume into density, that is total mass. Volume into density is mass, and gravity. So from this r equals to just rearrangement 3 QE by 4 pi rho g, and as it is cube root, we are writing the power as 1 by 3. Now we are going to substitute the values. So after substituting the values, we are getting the final answer as 9.81 into 10 power minus 4 millimeter. So please have an idea of all the different types of questions we see, and that will be useful in many other solving many other questions.